Welcome to this lesson on the distributive property, really critical lesson for moving ahead in Algebra 1. Please click like and subscribe if you find this video helpful. So if these illustrations and explanations help you at all, let me know that by giving me some feedback and leave a comment or question. Let me know what you think. If this video raises other questions for you, or if there's something you'd like to see me make a video on just to address your questions, please let me know that by commenting on the video. So we're going to take some time in this lesson to see what this property is and where it comes from. And we're going to do this by visualizing a rectangle and its area. So starting off, like we can draw a little rectangle here, and we're going to use a 4x7, but I just picked those numbers out of the air. You can pick any numbers you want, and you can do a similar illustration with them. And if you don't remember from earlier math, if we were to divide this into like 7 units here, so 1, 2, 3, 4, 5, did I get 7? 1, 2, 3, 4, 5, 6, 7. And we divide this one into 4s. Okay, we can find the area by basically counting up how many boxes we have. So we have 7 boxes by 4 boxes. And so if you were to count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then this would be 21, and this is 28. And at some point in your math history, hopefully you had a chance to do that, to come up with the formula for the area of a rectangle. And so the area of a rectangle is equal to the length of its base times its height, okay? Or you might see like length times width, and you can see either one of those. They're the same formula, you're just using different words. So you might use base and height, or you might use length and width. At the end of the day, it's the dimensions of the rectangle. So you would like multiply them together. So we know that this rectangle has an area of 28 because when we multiply 4 by 7, we get 28, or you can actually divide it up into those boxes and you can count all the boxes and you can get 28. So it's really important to have that. Rectangles can become incredibly useful in Algebra 1. There's a lot that we can model with them, and I'm a huge fan of that with my own students. So in these video lessons, I'll keep coming back to rectangles. Now, suppose this rectangle was divided into 2 pieces. So instead of 4 by 7, let's say there was some kind of like a segment here, and you had a piece that was 4 and a piece that was 3. Okay, and so you've got like a square there, and then you have like this rectangle tacked on. Now, there are 2 different ways you could find the area of this. So let's just say I did not show you the rectangle on the previous screen, and we were just starting from here. And I said, okay, find the area of the rectangle. There are 2 different ways that you could find the area of this rectangle. The first way is to add the 4 and the 3 to get the 7 and then multiply by 4. So you might say, okay, we're going to do 4, which is that width, and then we're going to multiply it by the length, which is 4 plus 3. And so you'd add the 4 plus 3 to get 7, and then you would get the 28. And that's a perfectly valid way for you to find the area. Okay, I'm going to add them together. Here's the other way. Or we could find the area of each smaller rectangle and then add those areas together. Okay, and what we mean by that is we could find the area of this one. Okay, that would be 4 times 4, or 16, and then separately find the area of this one. This would be 4 times 3, or 12, and then if we added those 2 areas together, we would come up with the area of our rectangle. So that would look like this. That would look like 4 times 4 for the big one there, the square, and 4 times 3, and then this would be 16 plus 12, and 16 plus 12 is 28. And if I went back to that other slide where we saw all the little rectangles on the inside, all the little squares, because square is a rectangle, but this is not a geometry class, not a geometry lesson, so we'll leave that alone. But both of these ways are valid, and I want you to notice these 2 different ways side by side. So you could do it this way, where you add them and then multiply, and that actually gives you the same area as if you multiplied the two smaller ones and then added the results together. Now, what we've just illustrated there is the distributive property. Now, let's expand on this idea. Suppose one of those segments was unknown. Okay, so let's just look at this. And so let's say we know the height, and once again, we have it divided into two pieces, and this is a 3, but let's say we don't know what that piece is. So we don't actually know the dimensions of the whole thing. Well, now we're kind of stuck, okay? Well, I guess we could model it both ways. So you could take the 4 and then multiply it by the sum x plus 3. Okay, I don't know what x plus 3 is, so that's about as far as I can go. Or, as with before, you could find the area of each small one. So you could do 4 times x, which of course is 4x. And over here we could do 3 times 4, which is 12, and we could add those together. And so that would be another way. So we could have 4 times x plus 4 times 3. Okay, and I want you to just, I'll stop talking for a moment. Just give you a chance to look at that. All right, now we're going to keep expanding on this. So this would work even if we had more than one unknown. So now let's take a look at, suppose the height of the rectangle was an x, and then this was a y and a z. Okay, well now we could do take the y and the z and add those together to get that entire dimension, and then multiply that by the height of the rectangle there, which is x. Or we could find the area of each smaller one. So this would be x times y, and this would be x times z, and that would give us the same area. So this would work even if you had multiple variables, and it also works if you have more terms. So suppose instead of dividing the rectangle into 2 pieces, we divided the rectangle into 3 pieces. Like that should still work in theory. So suppose we know the height here is 2, but now we're dividing this into more pieces. So we have we'll call that x squared, and we have this is an x and this is a 4, okay? So we don't know what those all are. So if I wanted to find the area of this entire thing, I could take the x squared plus the x plus the 4, add those all together, multiply it by 2, or I could find the area of each individual one. So this would be 2 times x squared, this one would be 2x, and this would be 2 times 4. And both of those would give me the same area. Okay, now this is really, really, really flexible, and it actually does more than this, picturing that rectangle, because right now I'm only dividing it vertically with vertical lines, but this would also work if I divided it with some horizontal lines. So suppose we divided it this way, but we also divided this other dimension by something. All of this would still work. You could still find the area by finding the area of each small one and then adding them up. So this is a really, really great model. And if you've watched my video on adding real numbers, I'm really big on having a model in your head that you can picture so that you know what it is we're doing and somebody's not just telling you some steps. So this is as far as we'll take it for now, but this also works if both sides of the rectangle are divided. We'll get there later in Algebra 1. That is actually an Algebra 1 concept, but for now, we're just going to divide it in one direction. So for vocabulary, I want you to think of what it means to distribute something. If your teacher hands you a worksheet and says, here, distribute this to the class, you got this idea of you've got something and you're going to hand it to every single person in the class. So you've got your sheet, and if you don't hand it to everybody, then you haven't really distributed it very well, and your teacher's probably not going to ask you to do that again because you're not very good at it. In math, When we are distributing, what we're distributing is multiplication over addition and subtraction. So that's what we're doing. Now, there are some things, other things in math that look similar, but this is the strict meaning of what it means to distribute. So you have multiplication and you are distributing that multiplication over addition and subtraction. So even if you see some things later with exponents that look like distribution, we really want to avoid using that vocabulary word because that's would not be the right vocabulary word to go with it. Now, it's often represented with lines or arrows, but this is not necessary. So looking at like this example here, okay, when people are doing that multiplication to get the 2x and the 2 times 3, you will see people do this. They'll draw like a line, or maybe they'll make the line an arrow. Okay, I've seen both. And so they'll say, okay, well, I could do 2 times x, and then I could do 2 times 3, and you would write it underneath. I know in the earlier examples, I was writing it side by side, but that's because we were approaching the problem from like 2 different angles. You don't have to do those arrows. And in fact, I've seen students of mine draw these little arrows and then not actually do the distribution, which kind of lets me know that somebody told them to do arrows, but they didn't really know what those arrows meant. What those arrows signify is that you're taking that 2 and you're multiplying it by everything inside the parentheses. So you've got the 2, and then you have the x and the 3, and it's indicating that the 2 needs to be multiplied by the x, and the 2 needs to be multiplied by the 3, and so you've got that look of distributing. Now, the arrows are kind of nice because if you picture yourself handing out that worksheet in your classroom, you can almost picture your hand moving like that little arrow, like you're distributing it, and you're flinging the papers at your classmates. So 3 quick examples of what this looks like. Let's take a look at this one. So again, teachers will sometimes do the little arrows just to give their students a visual line of sight. So they won't just do the distribution, they'll do the little arrows, and it's part of a teaching strategy to make the math a little bit more visual for you, but it's not actually a step that's required to be shown. So when we distribute, this would be -3 times x plus -3 times 6. -3 times x is -3x, and -3 times 6 is -18. You can leave it like that. Most people will take that plus negative, and they will write that as a minus sign. And that's a place where that plus negative can come in very handy because you see what it is you're distributing there. I've had students when I've done like a -18 and then they get confused and they're like, is that a -18 or is it subtract 18? And I'll answer yes. And then my students are not happy with me because I have answered yes. But using the plus negative can help ease that transition into, okay, what am I looking at here? Same thing can happen over here. For some of you, it might be good to write that as plus -5 so that you are recognizing that that is a negative number. The subtraction symbol there, that's what that means. And if I'm confusing you with that, please go check out my video on subtracting real numbers, where we do a bit of a deep dive into what we're doing when we're subtracting. Now, I'm not going to do the little arrows this time. That is 2 times x plus 2 times -5. 2 times x is 2x. 2 times -5 is -10. Or if you would prefer, you can say 2x minus 10. Now, typically, if you can do it in your head, we will. So I'm going to go ahead and put bit of a brackets around these and make a little note. Usually we'll skip that step. I think when you're first starting to do distribution, you don't necessarily want to skip it when it's brand new, but as soon as you feel comfortable skipping it, then absolutely you should skip it. Now, this last one is distribution from the other side, and we don't usually see it written that way. Most of the time when you see this, the thing that you're multiplying by will be on the left. not on the right, but you could see it from the right. If it really bothers you, you want to remember that multiplication is commutative, and so you can always switch the order of your multiplication. So that means that 4 times 5 is the same as 5 times 4. So you can go ahead and rewrite it. You don't have to go and rewrite it, though. You're welcome to distribute in from the other direction. It just might look a little weird. So we're going to distribute this and say 4a. And then in my head, I'm going to look right here. Okay, so I'm doing 4 times a to get 4a, and then I'm going to do 4 times 3, but I know what 4 times 3 is in my head. I don't have to write 4 times 3 out, and I might just write plus 12. If you need to write it, then do it. Okay, so 4 times a plus 4 times 3, and you can write that step in. It's really individual. Don't feel like you've got to move faster through that than you're comfortable doing. Okay, so key idea here, combining like terms. I personally abbreviate combining like terms as CLT, which could also stand for classical learning test, but it doesn't right here, just because I get tired of writing out combining like terms, but that is something that's unique to me. Your teacher might not do that. So going over the vocab here, combine. Combine specifically in math means to add or subtract. And I will have students use the word combine to mean multiplication, and that it doesn't mean that. When we say combine in math, we mean to add or subtract. So combining like terms means adding or subtracting. Like means the same variable parts. So you are allowed to add and subtract things that have the same variable, and terms are things that are added or subtracted, as opposed to things like factors, which are things that are multiplied. And I'm aware that the word things is kind of a vague word there, but just bear with me. It's things that are added or subtracted. Here's what it looks like in terms of our distribution. Looking at 8x plus 2x. I can look at that as being 8 plus 2 times the x. So basically, we're undistributing it, and we're recognizing that if that were like the rectangle, then the x would have been on one side and the 8 plus 2 would have been on the other side. So it would have looked something like this. So you would have had the x, and then this would have been the 8, and then this would have been the 2. And so you had 8x plus 2x. And so we could write that as 8 plus 2 times x, which of course is 10x. Same thing over here. Now here it might help to rewrite that as plus negative 5x squared. We do want to remember that that minus sign is a negative number. And in this case, the x squared would have been the thing that they have in common, and we'd have 3 plus negative 5. 3 plus negative 5 is negative 2, and that's negative 2x squared. So this is something that we don't do a lot of times, is recognize what we're actually doing when we're combining like terms. Now, this next one, they are not like terms. So I have a 3x squared plus a 2x, and I have students all the time say, but they both have an x. Well, it is true that they both have an x, but they don't have the same x's. So this one has 3 times x, and this one only has a 2 times x. So they actually don't match, even though they both contain an x. If you tried to put that on a rectangle, it wouldn't work. If you tried to say, okay, well, we've got the 3 and the 2, but then what would you put on that side? It can't be the x squared, because then you'd mess up the 2, and it can't be the x, because then you would mess up the 3, and it just would not work. So we can't add or subtract things that don't have the same variable part. Now, typically we just add or subtract the numbers and we leave the variable alone. So I'll show you in this example here, we would not do that weird step where we try to pull it out. What we would do is look at this. We would say, I see a 4x plus a 2x, and I would say 4x's plus 2x's gives me 6x's. I often use a noun to illustrate that. So instead of x, I'll pick like my favorite noun, say kittens, and I'll say, okay, if you have 4 kittens plus 2 kittens, what do you have? And my students will say 6, and I'll say 6 what? we get 6 kittens. Okay, so we have 6 kittens. So instead of kittens, it's x's. If I have 4 x's plus 2 x's, how many x's do I have? I now have 6. And then we would look at the other piece, and we'd say that is a -3 plus a 7. And again, this is where it might be helpful for you to remember that that is plus -3 plus 2x plus 7, because then it's a little bit more obvious that the number that you're adding there is a -3, and that will give us a +4. So -3 plus 7 is +4. If that was tricky, please check out my video on adding real numbers. Please check out the practice set linked above and in the description box, and don't forget to like this video and let me know what you think. I will see you in the next one.